So when you write your answer, it's correct to say within 95% confidence. Now, the media, you may sit there and say, well, how come the media never actually gives me confidence level information? They only give me what? Margin of error information. They give you this. They don't talk about confidence level. Well, guess what? When they computed this, margin of error, when they computed it, they used this exact formula. And I believe the default in media, I think this is the default right here, the 5%, 95% confidence level. I think this is the media default. They use that confidence level, 95%. Now, on your homework questions, they're not going to give you all 95%. They can give you what? The 90% confidence level. They can give you the 99% confidence level. They can even give you a 98, a 94, or a 96. In which case, how do you deduce the critical value? The manner that I showed you this morning for warm-up. See, Eddie, there's irony in life. I know. There's irony.
So we don't convert it into percent, we just leave it like that?
No, you leave it like this. Okay. Should we give these guys a break then? You guys ready for a break? Because I could keep going. Ready. Okay. All right. Give you guys a break. We'll be back in 20 minutes. Yeah, I know. I know.
That's cool.
I know. I told them
Did
this.
you hear about this guy? Our president last year that got arrested for all that.
This is the format that you use when you estimate the true proportion. Okay? You also have a format that you use when you estimate the true mean. Estimate mu. Mu is a true mean. So here's the format. It's a sample mean minus the error. Less than the true mean, less than the true mean, plus the error. Okay? So far you have two formats here. They do have a different error formula. It's z alpha over 2 s over the square root of n. Okay? So, the morning lecture was designed to prepare you for the remainder of these sort of questions. We're now going to estimate the mu. So, for example, we can say something like this. A sample of 250 college students indicated that they drink 2.85 cups of coffee per day, with a standard deviation of 1.5 cups. Use the 90% confidence level to estimate the true mean. No, just leave it at that. Estimate the true mean. Okay? And so, like the prior question or the prior setting, it's going to tell you to do what? To estimate. So what is this going to tell you to do? What are the instructions here? To estimate. How did you know? It says it. What are you going to estimate? The true mean. So once you identify what they're asking of you, they're asking you to estimate the mean. What's the format again? It's a sample mean minus your error. Less than true mean, less than the sample mean, plus the what? Error. Where the error is z alpha over 2 s over square root of n. This is your format. Okay? So, what do you have to identify again? What do you identify? The sample mean. Okay, do you guys see sample mean anywhere? Why do you know the sample? I mean, why are you going to say that the sample mean is 2.85? Let's think about this. All they indicated was that you had a sample of what? 250 college students. Is that true? So you know you have a sample of 250 college students, and they indicate that they drink how much? 2.85 cups of coffee per day. How in the world can 250 people drink 2.85 cups of coffee? What does this value really mean? That it's a what? That this is the mean. Okay, so what happens is sometimes they'll say this is the sample mean. Sometimes they won't say it's the sample mean. But it's implied because there's no way 250 people, they're saying that this is the mean here. Okay, so they're going to imply that that's the sample mean. Just like Moshe said it's 2.85. They didn't say this is the sample mean, but that's what they're implying. So this is going to be 2.85 and you're halfway there. All you have to do now is determine the what? The margin of error. That's all you have to do. So how do you determine the margin of error? Here's your error formula. Okay, so what is this value here again? This is your what? Critical value. What is this S again? What was that S again? Sample what? Standard deviation. What is that? How do you know it's 1.5? Tells you. And what is N? How do you know it's 250? Tells you. But what in the world is the critical value here? Can anybody tell me what the critical value was? What is it going to be? Why is it 1.645? It's 1.645. Why is that? Well, because they told you use the what? The 90% confidence level. The 90% confidence level. Remember that warm-up process we did this morning? That is how you deduce this z value of 1.645. Okay? That's how you do it. Now, we summarized all that information here. If it's a 90% confidence level, what's the critical value? 1.645. Okay, so guess what you're going to have to do on a test? Yes, exactly. Right, you're going to have to deduce this. Okay, so on a test you deduce this stuff. Exactly. All you have is your chart. You have your formula sheet. Is this a formula? Is this the formula right here? No. It's a table. What does that mean you have to do then? You're going to have to go through, remember our warm-up we talked about? You're going to have to go through that warm-up. Okay? So this is 1.645. How do we deduce the error? 1.645 times what? 1.5 over the square root of 250. Enter all this information in your calculator, and you're done. What is it? It's a 0.15605. 0.15605. You're getting that approximate value. But what was the mean? 2.85. So you're going to go out, approximate the error to the nearest what? Say that again. Okay. So we're going to approximate this. How are we going to approximate this value? If this mean is to the nearest hundredths, we're going to go to the nearest what? Thousands. So our error then is going to be approximately 0.15. Look at the 0, 6. This is your error formula. Okay? So you're done now. 0.156. 0.156. So what you're going to do is you're going to take the mean of 2.85, add 0.156, take the mean of 2.85, subtract 0.156. What do you get? 2.694 less than the mean, less than 3 point. And you can say this with what? 90, is it 90%? Okay. You can say this with 90% confidence. So that the true mean number of cups of coffee, is that right? The true mean number of cups of coffee is between 2.694 and 3.006 cups. You say this with 90% confidence, and what does that 90% confidence mean again? That if you were to take an arbitrarily large number of samples of size 250, 90% of the time, the sample mean will live between these two values. Okay? So I want to point this out to you now. The process you follow is identical. It's just that the setting is now a mean setting versus a proportion setting. The error formula is different, but it has the same analogous format. Okay? So if you're in the section, here's the thing about it, right? Again, we'll go through the logic. If you're in a section that's about estimating a proportion, what do you think, even without reading the question, what do you think all those questions are going to be about? Estimating a what? Proportion. What if you're in the section that's studying estimating a mean? What do you think all those questions are going to be about? Estimating a mean. Okay. So when you read the question and it says estimate proportion, use a proportion format. Estimate the mean, use the what? The mean format. And all these things work the same way all day long. So here's the thing about it. Let's think about this. It's based on what this value is, the mean value. So the question is, why are we actually going to the thousands to approximate this? Because you see the mean here, you see this? You see this? What was that value at? The nearest what?